this is the so today we'll discuss about the way we measure the correct rainfall uh, when or we test the consistency of the record for a certain number of rain gauge station. The problem will be given like this. Suppose we want to test the consistency of G1. We have another two gauge station there, G2 and G3. And suppose for the year 2021, annual average rainfall data is given 2020, 2019, 2018. These are given annual average rainfall of G1. So let us see, this is 10, suppose 12, 14, 20. Similarly for G2 and G3, 7, 14, 16, 21. G3 is suppose 4, 8, 10, 12. So these are all given. Now I want to test the consistency, or we want to find the correct rainfall of this G1. And all these are annual and average rainfall data. Okay. So the procedure is, first step will be to find the average rainfall of the other gauge station. If you are measuring the G1, consistency of G1, then you have to find the average rainfall as measured by the other gauge station or neighboring gauge stations. So in this case it will be G2 and G3. So 7, 4, 11, it will be 11 by 2. So it is nearly, sorry, it is 11 by 2. .5. This will be 14 plus 8, 22. 22 by 2. 2 by 2 is 11. Then this will be 26 by 2, which will be 30. And this will be 33 by 2. So this will be 16.5. So next step will be find the mass curve of this as well as this. Find the mass curve of this part, which is G1, and also the mass curve of this average rainfall of the other neighboring gauge stations. Here the neighboring gauge stations are 2. So we are doing all this with these 2 only. It may be more than 5, 6, 7, as many other rain gauge station is available in that single watershed. You have to use all of them. So the step 2 will be to find the mass curve of this for this G1 only. Okay, so how the mass curve is prepared? So as you know, you keep this as 10, this as next value will be 10 plus 12, 22, then it will be 36, that means 10, 10, but the next will be 10 plus 12, 22, third one will be 10 plus 12 plus 14, 36, then 36 plus 20 will be 56. Similarly, these two, the first point of this G1, G2, this we will draw another another mass curve with the help of this data. So the first one will be as it is 5.5, second one will be 5.5 plus 11, 16.5, then 16.5 plus 13, 29.5, then 29.5 plus 16.5, this will be 46. So this is the mass curve for that other neighboring gauge stations. Now we draw a plot. So in the x-axis, this G1 mass curve. Let us say these x-axis are the years 2019, 2000. Sorry, start from 18, so 18, 19, 20, 21. And here I will draw two mass curves, one for G1, another for G2. So one will be G1. So this will be like 10, then what is 22, is it 10, 22, 36, 56, 10, 22, 36, 56. Then for this another curve of this other base stations, 5.5, 16.5, 29.5. So 5.5 this one, 5.5, 16.5, 29.5, 46. As you see, this is one curve and this is another curve. Now both are deviating with each other. So what we have to do is we have to find out the S1 of this curve and S2 of this curve. And as you know, the S1 is nothing but the maximum height. Suppose in this case it will be the final value of y, which is the highest y value. So final value of y minus initial value of y, correct? And divided by so here we'll in the step 3 what we'll do is we'll find the slope of the that mass curve of G1 and slope of mass curve of all other gate stations, correct? So for both the formula is like this: y final minus y original or initial divided by x final minus x initial. Now y final and y final for the G1 mass curve, it will be y final is 56 minus initial 10, and x final will be there are 4 years you are using 4 minus it will start from uh, 1, so it will be 3, 4 minus 1, so this is 56 minus 10, 46 by 3, so this will come, so this will be like 46 divided by 3, 15.333 and so on, so 15.33. So S1 is your 15.33. Then S2 will be Y final is, as you know, it is 46. Y initial is 5.5 divided by same 4 minus 1, 3. So it will come as 40 by 3. So it's not 40 by 3. This will be 40.5 by 3. So it is coming 13.5. 13.5. So there is a deviation between S1 and S2. So how to find the percentage deviation? 15.33 minus 13.5. We are trying to find the deviation with respect to S1, not with respect to S2. So in the denominator, you will give the S1 value, that is 15.33. So this is coming. What is the result? let us see, 15 point minus 13.5, 1.83. So 1.83 divided by 15.33. So it is coming 0.119, which we can say as 0.12. So this is the deviation that was found between H1 and H2. H1 is the slope of the mass curve of gauge 1, and H2 is the slope of the mass curve of all other gauges. Correct? Okay, so 0.12 is the deviation, so around 12% is the deviation that is what found. So if the answer states at how much deviation is there, then up to this you will calculate. But if it says that also calculate the correct precipitation, and it gives the correct precipitation of that day as measured by G1 as 5 millimeter, then just multiply 5 with 0.12. So this will give, so just multiply 5 with 0.12. So basically, so sorry, you just multiply 5 with 0.12. So this will give the 0.6. So now you will deduct this correction from your original rainfall, and it will come around 4.4 millimeter. Correct? So 0.12, the 0.6 is the correction factor. Then you minus the correction factor from the precipitation measured by the gauge station to find the correct precipitation. Okay. So this is what the procedure of measuring consistency with the help of double mass curve method, and also to find the correct or actual precipitation of our gauge station.